Distance, rate, and time problems here. These are the ones where you have trains and cars and boats and whatever else you might be doing. I kind of like to draw pictures as I go because it helps me to see in my head what's going on. Two trains leave the station at the same time. One headed west and one headed east. The westbound train travels at 100 miles per hour. The eastbound train travels 90 miles per hour. How long will it take the two trains to be 494 miles apart? Well, we know that if we take the rate times the time for each of these, we get the distance. So the rate of the westbound train was 100. The rate of the eastbound train is 90. We are looking for how long, so we're trying to find the time. So the distance here is 100 times the time. The distance here is 90 times the time. If we add them together, our total distance is 494 miles apart. So 100 plus 90 would be 190, combining those two things. And in order to solve that, of course, all we have to do is divide. 494 divided by 190 gives me gives me 2.6. So my time is 2.6 hours. Tells me not to round it off. So 2.6 hours is how long it would take them to be 494 miles apart. Number 5, Deborah drove to the mountains last week. There was heavy traffic on the way there, and the trip took 6 hours. When Deborah drove home, there was no traffic, and the trip only took 4 hours. If her average rate was 22 miles an hour faster on the trip home, how far away does Deborah live from the mountains? So she went to the mountains, then she came home from the mountains. Those two distances should be the same. Again, we want to think about the rate times the time for those two distances. So, there was heavy traffic on the way there. The trip took 6 hours. So my time here is going to be 6 hours. When Deborah drove home, there was no traffic. It only took her 4 hours. So the time on the way home, 4 hours. Her average rate was 22 miles an hour faster on the trip home. We don't know what the rate was on the way there was. We're just going to leave it as R. But we do know on the way home she went 22 miles an hour faster than what she did here. So R plus 22 would be her rate on the way home. We know that those two things should be the same because if I went someplace and came back, should be the same distance. So R times 6 would be 6R. That's going to equal 4 times our R plus 22. So it looks nice, right? If I take 4 times R plus 22, I can write it as 4 times R plus 22. So now I have an equation I can solve. 6R plus 4R plus 88, using my distributive property. 6R equals, I better write the right thing there. 6R equals 4R plus 88. Solving that for R, I need to move my R to the other side. I'm going to minus that 4R. So 2R is going to equal 88. Then, of course, I'm going to divide by 2. R equals 44. Now, we don't want to know the rate. The question doesn't say how fast was she driving. The question says, how far away does she live? So we need to find the distance. We can substitute that 44 either going to the mountains or coming home from the mountains. We should get the same distance. To me, the top one looks easier to do. 44 miles an hour times 6 hours. 44 times 6 gives me a distance of 264 miles. I could have done it in here and with 44 here. 44 plus 22 would have been 66 miles an hour for only 4 hours. If I take 66 times 4, I get the exact same answer, 264 miles. I should, it's the same distance. So when you look at it and you get your answer, you got the rate, but you have to answer the question they want, which is how far away, what is my total distance? Rate times time in either one of these should give me the same answer. Number 6, 2 trains leave the station at the same time, one headed east, the other headed west. The eastbound train travels 16 miles an hour faster than the westbound train. 2 trains are 510 miles apart after 3 hours. What is the rate of the eastbound train? So again, I'm going in 2 opposite directions. The eastbound train is going 16 miles an hour faster than the westbound train. It's kind of like the previous problem. We don't know the rate of the one going west, but we do know the one going east is going 16 miles an hour faster. So my rate for my westbound train is going to be R. The rate for my eastbound train is going to be R plus 16. Rate times time. They both went for 3 hours. So I'm going to times them both by 3 hours. We know the total distance was 510 miles. So R times 3 would be a distance of 3R. Here we want to take 3 times R plus 16. I know the total distance, 510 miles apart. Now I have an equation I can solve. So 3R plus 3R plus 3 times 16, 48, equals my 510. Combining my like terms, 3R plus 3R is 6R plus 48 equals my 510. Solving that for R, I've got to move my 48 to the other side, so I'm going to minus that 48. 6R is going to equal 510 minus 48, which is 462. And then, of course, to find R, I've got to divide by 6. R is equal to 77. Now, the question wants to know what is the rate of the eastbound train. What did we find? We found R, and R was the rate of the one headed to the west, right? This is the west and this is the east. So 77 is not the answer to the question. The westbound train was going 77 miles an hour. The eastbound train was going 16 miles an hour faster than that. So we have to take the 77 plus the 16 to find the rate of the eastbound train. 77 plus 16 gives me 93. So 93 miles an hour is how fast that eastbound train is going. So you have to be really careful on these ones that you're actually answering the question that they're asking. Just because you get down to an answer at the bottom doesn't mean you're done.